However, this is not the whole story. It turns out that light is and should be and can be described as a wave sometimes, but then other times it's actually best to describe it as a little particle, as a little bundle of energy. This is known as wave-particle duality. I believe we talked about this a little bit when we were studying the electron back in our unit on chemistry and on the atom. Electrons can also be thought as particles and waves at the same time, just like light. So in some cases it's best to model light, to view it as and think about it as a wave. Sometimes it's best to view it and think about it as a particle. But what does it mean that light can behave as a particle? This basically means that light can always travel as little packets, bundles, or particles of energy, little packets carrying specific amounts of energy. That phrase, specific amount, is contained in this word quantized. So we say that energy is quantized, light energy is quantized, it comes in specific amounts. In other words, what I'm saying is that the energy carried by light is analogous to a set of stairs and not analogous to a ramp. So in other words, light can carry this amount of energy or this amount of energy or this amount of energy or this amount of energy, but not in between. You cannot exist in between these stair steps. So light cannot carry any amount of energy. It can only carry specific, discrete quantities, packets, bundles of energy. So sometimes it's kind of helpful, and this is very, very odd and strange. I know it's counterintuitive, and it's really impossible to even imagine. But we know this is true. We have evidence for this. I don't have time to get into it. The mathematics of these theories works out. But basically, you can say that light is this. It is a little tiny bundle or packet or particle of wave energy. So this might represent a photon. This photon has wave-like properties. It has particle properties. It's traveling. It's carrying a certain amount of energy with it. That is a photon. A photon is a particle of light. Well, it turns out that the energy carried by a photon is given by this equation, hf. The energy of a photon equals h times f, where f is the frequency of light. Remember, we already said that energy is directly related to frequency. So as frequency goes up, the energy of light will go up. And this h number is right here, and it's known as Planck's constant. So basically, this is the minimum amount of energy that a photon can carry. And light energy, photons, particles, packets, bundles, discrete quantities of light have to carry energy in some ratio of this value. This is known as Planck's constant, named after a dude named Max Planck, sometimes pronounced Planck, who helped discover these things. The first scientist to really discover this model of light, that light is a photon, it's a particle, it has to carry energy in specific quantities like stair steps, not as a ramp. That light exhibits wave-particle duality, that light is a particle, it's called a photon. In fact, the first guy to use that word photon is none other than Albert Einstein. So Thomas Young, way back in the 1700s, said light is a wave because it exhibits interference patterns, all this other stuff. Einstein in the early 1900s said, wait a second, we have evidence that light is actually a particle, a photon that carries specific amounts of energy. Who's correct? Yes, both of them are. Light is a particle and it is a wave. We're obviously in this unit going to be focusing in on the wave aspect of light, talking about the electromagnetic spectrum, which requires us to view light as a wave with wavelength, frequency, etc., etc. But the photon idea is important, and you will need this equation. The energy carried by a photon is directly proportional to the frequency of light and is proportional to this Planck's constant number. So, a summary of all of that. Light is the wave-like energetic excitation of the electromagnetic field caused by the behaviors of charged particles. When charged particles wiggle around, they excite and cause ripple in the electromagnetic field that propagates outward as a wave of energy. We know that light exhibits the properties and behaviors of waves, such as frequency, wavelength, reflection, interference, etc. Light can be classified into different types based on its wavelength, frequency, and energy. That's the electromagnetic spectrum. Your eyes have evolved to only interact with a small part of that spectrum. And we know that light can be modeled as a packet or a particle or bundle of energy, and that is called a photon.